welcome. Thank you for coming. Let me make adjustments here. Okay, so today we are going to be doing something fun. We're going to be doing a pair programming demo. Need to hit one more button here. I think we got everybody on. Can everybody hear me okay? Give me a thumbs up. Say something in the chat if you can hear me okay. Make sure. All right. Okay. Okay, I think we're set. Okay, so this is my son Benjamin. He's going to be helping me out. We're going to be doing some pair programming here. Oh, that's weird. We kind of shows through. I guess my shirt's got some green in it. Coming up, I do want to mention, not next week, but the week after that, we're going to be talking about another discussion of test-driven development, but this time talking about how to use ChatGPT to help or possibly hinder your ability to do test-driven development. But Jason Sweet's going to be helping us with that. He's got some interesting ideas on it. I've seen a little bit of his stuff in this area, and it was very interesting to hear his thoughts on stuff. So that's coming up, not next week, but the week after that. We should be in. I'm still trying to decide what we're doing next week. We'll see, or we may take it off because of holiday. Okay, so we are going to be looking at, we're going to be using a programming language called Racket. And what we're going to do is we're going to take a simple problem and pair program. So the way that pair programming works usually, or the way most people just describe it, or have seen it to work well, is two people sitting at a computer, and one person writes a test and gets a test that's failing. Then they pass it to the other person and say, ha, can you solve this? And anyway, the next person gets that test to pass in the simplest way possible, and then writes another test. When that test is failing, that passes it back, and then the person who started gets it to pass, writes another test, and you just kind of ping pong back and forth. There's a couple reasons that this can be effective. One, it gets you really focused on just how to take that next step. So instead of thinking in big terms of how can I solve all my problems, you're thinking more in smaller terms of how do I just incrementally improve this. And you're going to see that as we go through here. We'll have a lot of stuff where we do something one way and then come back and rewrite it in order to get to evolve to what we're trying to get to, instead of just trying to picture it all in our mind to start with. The other thing it does is it's a very engaging way to work. Oftentimes you hear people talk about pair programming like, well, you've got one person reading Facebook and the other person writing the code, and then they switch. That's not pair programming. That's just one person being lazy and switching off who gets to be the lazy person. Pair programming actually should be pretty active with feedback from both people, regardless of who's at the keyboard, of trying to discuss how to approach the problem. And that's contrasted a little bit with mob programming, where you may have 5 or 6 people, one person's at the keyboard, and often in those situations, the person at the keyboard isn't allowed to come up with anything on their own. They just have to type what the team comes up with that they're doing, and then they switch that out as they go. Okay, so we're working in a programming language here called Racket. Benjamin is probably more of an expert at Racket than I am, because he's done more programming with it, especially recently. And but the simple thing with Racket is it's mostly just lists of different things. So we'll explain some of that as we go through. But what we're going to do is start with Racket is a form of Lisp. If you've ever seen if you're a developer, you probably have heard of or seen this book, Structure, Interpretation of Computer Programs. This uses a programming language called Scheme. Racket is basically a descendant of Scheme. So that's what we'll be looking at here. Just out of curiosity, give me a thumbs up if any of you have ever done anything with some form of Lisp in the past. Cool. We got some people that have. Okay, and some people that haven't. That's fine. The nice thing about it is it's fairly simple, so we shouldn't have a problem figuring out how to do it. So what our program is going to do here is we're going to create a convert program that takes a number, like an integer, 1, 2, 3, 4, 5, 6, an Arabic numeral, and converts it to a Roman numeral. So an interesting fact, the person that kind of really started promoting the idea of what we call Arabic numerals, or the numbers-based 10 system that we're used to, was Fibonacci. And he was the guy that came up with the Fibonacci sequence, which is the Fibonacci sequence, which we use for, so some of you probably use for sizing stuff. So interesting historical note. Okay, so I'm going to start here, and I'm going to first write a test. And you tell me if I'm writing this right. Is it check equal?
I believe so.
Okay. So check equal. And we're going to say, and Did I introduce you? This is Benjamin, my son. I think I said that. He's 13, and you're going into freshman, right? You're just starting.
I think so.
Freshman, yes. Okay, just going into ninth grade. Okay, so what's the simplest thing we can do? We want to imagine that we have a method. You remember? Is it expected first?
So usually what you do is you usually call the method first.
Call the method first. Okay, so we're going to check equal, and we're going to say we'll just call this method convert, not convent, convert. Okay, and if we convert with 1, we expect to get the letter I back. And if the syntax looks a little bit weird, you're probably used to seeing things that look something like, you'd probably normally see stuff that maybe looks something like this. If you're using Java or something, and then you've got different things inside here. Lisp languages are a little bit different. You start an opening parentheses, and then you name your function, and then you have a list of all the parameters to it. So it's not really any different. It's just a matter of if you have trouble figuring out what we're doing, just pretend that we move this over there, and then it will look all familiar. Okay. So we're going to call a method called check equal, and this is just an assertion. We're going to say and check to see if this is equal. If I call convert and 1, I get back an I. Now at this point, if I try to run this, it's going to fail because it doesn't know how to do a convert. So I'll go ahead and write that. So we're going to define a function called convert that takes an integer. We'll just call it I. And then I'm going to have it just return X. Okay? Now that should fail, but we should get an actual failure now. So over here on the right is where we expect to see that. And yes, it says it's a failure. It expected to get an I, and instead it got an X. You've messed up your program. Figure out how to make it right. Make this full screen. Okay. So we've now got a failure. So in pair programming, what we do is I then take the computer and pass it over to Benjamin, who's been watching carefully and saw my horrible mistake in the code. And he's going to get the code to actually pass. Doing the simplest thing possible. Okay, so in this case, he just makes it. Okay, so he got the test to pass. So now it's his turn to go ahead and come up with a, let's go down. So do it underneath.
We're going to do the base case.
Okay.
So what my dad did is he started at 1. But what happens if I pass in the letter 0, in the number 0, or something that says cats are furry? What will it return? Will it return an I? I don't really want it to do. So what happens if I pass in 0? I want it to return an empty string.
Okay. Did the Romans actually have a concept of 0?
No, but...
Okay, so I've got a test now. And if you notice there, Benjamin thought of a case that probably should come before where I started. And this is, I did not do that on purpose. Although when we practiced it, I did the same thing, didn't I? Okay, I always jump the gun. I didn't do that on purpose, but it's an example of, yes, Astrid, he'll make a very good tester. It's an example of the types of things you get with pair programming where it would be easy for me to skip something, but if there's 2 of us thinking about it, especially if it's me and I always skip the base case like that, somebody else may catch it. So now I've got another test here, and we run it, and it doesn't work. So it's getting back an I. So I'm going to then come in here, and I need to figure out what to do. So I'm going to just do the simplest thing I possibly can, and I'm going to say if. So keep in mind this is an if function, and then I've got an equal function, and I'm going to say if I equals 0, because remember I've got my function first, so this is basically testing to see if I equals 0 here. I know it looks a little weird, but you get used to it pretty fast. And the way the if statement works is I have an if is the function, and then the first thing here is going to be what I'm checking. The second thing will be what to do if it's true, and the third thing will be what to do if it's false. So I'm going to replace that false with just saying, okay, if it's false, I'll just return the I. So that will be my what to do if it's false. If it's true, I'm going to return nothing. Okay, so this should give me, if I equals 0, then return just an empty string. If it doesn't equal 0, then just return an I. So I'll run that. Okay, and I made a problem. I need to close the parentheses here. Okay, so there I've got it. I've defined my convert to take an integer, and it will check to see if I is 0, and if it does, it returns just an empty string. If not, it returns an I. Now, at this point, if you are a developer, you are probably thinking of all the other things you could be doing here and how this is a horrible approach to this problem and that you should do this or that. Or you probably got all these things going on in your mind of better ways to approach this. And you are 100% right that there are better ways that we will to solve this problem. But remember, we're not trying to solve the whole problem. We're trying to incrementally grow a solution rather than trying to start with the solution. Because, and I like this problem because when I've tried approaching this without TDD, I end up jumping ahead in ways that slow me down tremendously. But if I use TDD and walk through it, it takes me step by step until I get an algorithm that's reasonably well formed, and it points to solutions that I wouldn't come up with if I tried to jump. Okay, so now it's my turn to come up with to break it again, right? To come up with another test for Benjamin. So I'm going to look for number 2.
And yes, it did pass.
Oh yes, okay, let's put that thing in we put last time. So I'm gonna, that's right, you can't see when I'm hitting the keys. Should I put, definitely, it's a big deal at the test run, right? Okay, so now if I run this, you'll see over here, okay, I've got a failure, but now we'll always see the test run, so if it does pass, it shows you. The way Rack Unit works, it's not quite as excited about things passing as I would like it to be. You know, it should like do party sounds and stuff. Okay, so we've got failing test. We'll pass it to you.
Someone asked in the chat how TDD differs from BDD.
Okay, so that's a good question. So TDD is test-driven development. What we're doing right here, what we're doing right here is we're using test-driven development. So we're writing tests from the standpoint of the developer. Behavioral-driven development is when you start from the standpoint of how would a user interact with this. So with behavior-driven development, instead of thinking of what does this method do, we'd probably be starting with when I go to this page as this user and I try to do this, then here's what I expect. So I think of BDD as kind of from the outside in or from the top down, and test-driven development being from the bottom up. Okay, so what's your plan for the simplest thing? Are you going to nest some if statements?
So I nested some ifs.
Okay.
And am I allowed to make it more clear and concise?
Okay, so what we've done now is we've got something the simplest thing possible that passed. So in our TDD loop, I should have put it up here, but we start with the broken test. We write the simplest thing that would pass for it, and then there's another stage here. If you leave this stage out, you'll get yourself in trouble. The next stage is try to see if there's a way to refactor to make it better. So what Benjamin was asking is, this is kind of messy and dirty. Reindent it, that might make it easier to. Okay, so we've got an if statement, and it says, if I equals 0, then return a blank. And then the next thing is the else, and it says else, so this is an else, if I equals 1, then return I, and then else return 2. All right, so we've got all these things, but Benjamin's right, this is messy, it's kind of hard to read. So he's now now that he's got it to pass, he's going to refactor. But notice what he's doing in refactoring is he's not going to change any functionality. He's not adding a new test. He's going to go ahead and just say, can I keep the same functionality, but write this in a way that's more clear and better? So what are you going to do? How are you going to refactor?
I'm going to use a function called cond. And cond is basically like a bunch of ifs stacked on top of each other. So it goes, it asks a question, and then it tells you to perform an action if the question is true. Okay. So let's start at 0. So if I is equal to 0, and you need the parentheses because that's how Racket knows you're calling a function. If I is equal to 0, then we want it to return an empty list, and then closing bracket. You don't have to use a bracket, it just makes it easier to read. Okay,
so what you're doing right here is you're going to try to replace all those if statements down there with something that does the equivalent.
Yes.
Okay, and if you see, this cond looks very much like a case statement, and like it's checking something and then it does it. Cond does not fall through though. So once it hits one, it calls that, it doesn't execute the rest of the things in cond. Check the chat thing, see if people have questions.
Okay, now I'm going to... Yay, now my simpler version passes.
So somebody asked, John, you asked why use an obscure language when trying to teach new concepts as an extra layer of complexity. I had a pairing partner in my house that's best at this language, so so that's why we're using Racket. Plus, it's the syntax is easy enough to understand. That's why it gets used for a lot of teaching things. That I figured it was a pretty good place to start. And there may be some developers out there that might find it interesting. Okay, well, John, I might take you up with that. We have to try that. That sounds like a good idea. Okay, where are we at?
Okay, so I got something that fails.
Okay.
I wrote.
So you refactored. We've now got a simple that, and that's a lot more clear. Does that? Let's ask our audience. Does that look more clear than those nested if statements? Is it easier to see what's going on even if you're not familiar with the programming language? Easier to tell. Okay, cool. Okay, so now we've got another test here. So we can look at this and say, okay, so I'm going to do the simplest thing possible, and I've got a good plan here. What if I just do this? I'm just going to copy that down here and change this to 3. Will that make it pass? Okay, so that passed. But now as I look at this, I'm seeing a pattern here, right? I've got I. And so I'm going to stop and think, and I could go a little bit further, but I think this is probably a good place to do it. I'm going to stop and think, is there any way I could make this more succinct? Can I refactor this in a way that makes it a little bit more programmatic instead of checking for every single letter that's out there? So you probably noticed this pattern. I just keep adding I's to it. So at this point, if I could just call myself again, I'd probably have everything I need. So I've got this base case that will return nothing. But once I get through with that base case, what if I were to do something like return an I? So this is a method called string append and does exactly what it sounds like. It appends a string to whatever I call here. And I just need one less than it. So if I go I minus 1, I might not need any of these other things. So let me just comment these out for just a second, just in case for some reason, did I make a mistake?
You'll need to do greater than or equal to 1, or else you'll get to a thing where 2.
Oh, okay, so let me run it. And, well, okay, so I don't have the right.
You have an extra bracket at the.
Oh, is it way over there?
Okay, so convert, you need an extra paren.
Okay. See, this is why I have the expert helping me with this. Okay, so I've got a failure. It got back void when it expected to. And so what you were saying here is when I hit this, if I hit this with 2, I need to actually call it. I'm just falling through. Okay, so I need greater than or equal to. Does that work?
Less than or equal to.
Oh, okay.
No, wait.
No, I think it's greater.
Yeah,
well, we've got tests. Let's find out. Okay, that works. The test ran. So I've just reduced the amount of code here pretty significantly. Format that. Okay. So I've now got one line that does that. And this is, what we did here was recursive. So if you don't work a lot with recursive stuff, this might seem a little mind bending, but I'm just saying, I'm going to take one I, I'm going to take an I and I'm going to output that or put in my buffer. And then I'm going to say, okay, and then whatever convert would do with one less than whatever I was given, smash all those things together, and that's what I'm going to show the user. So let's see, will this work for us, right? This is going to give us everything. So I just add a 4 here. And now, okay, got another failure because it's giving us I instead of IV. And Benjamin mentioned the other day that actually was used some places instead of 4, but we're going to go with the Roman numerals everybody probably learned in school.
If I is equal to 4, then we want to return IV. And once a con gets something that works, it stops there, so it isn't going, oh, it's greater than 4, and it's also greater than or equal to 1.
Right, just the first match it hits. And the way, I think I mentioned this, but you may be used to seeing return statements. If you think of Racket as just being kind of like an algebra statement that everything gets down to, and then whatever's left over is what gets returned, that's what it's doing. Okay, so I've got another one here. We expected to get V back for 5, but instead we got IIV. So it sounds like something's not quite right. Think clocks use... Oh, yes, I have heard that some clocks use the I because if you saw it from the back, it would be very hard to tell the difference between 6 and 4 or something like that. But I've also seen some old Roman coins that actually had 4 on it as well. So I think that must have been used in some cases. Or maybe the person they had making the coins couldn't spell in Roman numerals. That's possible too. Okay, so this looked like a pattern I can probably copy. What happens if I just do this? So Benjamin tossed it back to me. I'm going to see, does that give me what I want? Okay, so let's add another one here. What happens if I add this?
Should fail.
I think it will fail. And actually, that's a good point. One of the great things to do when you're getting ready to run your test in your pair programming is predict what will happen. Because some of these tests, we're going to write a test that happens to work, right? And we'll have to write a few more till we get to one that breaks. But having that conversation of, I think it's going to fail, and I think it's going to fail in this particular way, is a really good way to make sure that you're both thinking about what the program does and that you understand it. Because if Benjamin thinks it's going to fail in a particular way, chances are he's probably right. But if he thinks it's going to fail in a particular way, and I think it's not going to fail or fail in a different way, that means that our view of what the program's doing isn't synced. And we can have that conversation. Now, these tests run really fast. But if you have something that takes a few seconds to run, that's a great thing to be discussing instead of, checking Facebook or whatever. Okay, we thought it would fail, and Benjamin was right. It failed. So that means I get to pass it back over to him.
Okay, and the simplest thing is just writing the 6.
Yeah, Astrid, that's a good point. Failing for the right reason. If it fails in a way you're not expecting, there may be a problem.
Okay, so could we do the same thing with 5 that we did with 1?
Okay.
So what I'm saying.
Okay, so you got it to pass, and what you're saying is now, is there a way to refactor this to where it works better? Okay.
Is copy this and replace with this and that with 5, and then run that, and yes, that failed because we need to switch the I.
Okay, so it failed because it added an I to it, but added it to the beginning.
Yes, so that would be like
Okay.
saying 6 is equal to 4, which is if you're looking at the clocks we were talking about, it would be. Okay, and then I can delete that. Okay, now let's see, do you think 7 is going to pass? Think that's going to pass?
I think it'll pass. And this is why I try to make sure he's the one at this stage, so he has to write all of these tests by hand.
Okay, and then
Okay, so we're on a roll here, right? Maybe we've solved all of the Roman numerals. We're in good shape. All of these are going to pass. I'll just sit here while Benjamin types out the next 3,900. Oh, no, it passed. Okay, so we've got a failure here. Well, in looking at, and the reason it failed is we've now got a new character we haven't had before, right? We haven't ever hit a x. So the pattern we have is probably this is the closest thing we've had so far. So what if I do this and I give it ix for, and we hit 9. That make it pass? Okay, that made it pass. Will 10 pass? Nope.
I love what I think it should be IXI, but
Yeah, it's 9 plus 1, right?
Yes.
So it works, kind of.
okay. Then I'm just going to return X. And, oh, great.
Okay, well, this will work. Oh, yes, you got.
No, this is going to be fail.
You think it's gonna fail?
Yes.
I think you're right. I think you're going to pass it to me for writing all the tests.
I'm very confused how that passed.
Okay, well, it works. Let's keep going.
Oh, do you see how it passes? Because it's not equal to 10, and so therefore it's greater than 1. So you run convert.
Oh, okay.
Oops. Actually, I'm not sure if we've done that before.
Yeah, we've run through this a few times. Tried not to do it so many times that we wouldn't make any mistakes. And Benjamin pointed out last time we did it that each time we come up with a slightly different solution for things. Oh, wait, no, that.
Oh yeah, I forgot how to count.
There's not a huge demand for counting in Roman numerals. Okay, this is where I think it's going to get.
Will it though? Yeah, yes, it will.
You think 14 will work?
14 shouldn't work.
Like this. Quick, someone call IXII for 911. That's great. I don't remember that in the movie, but that's cool. Okay, we got a failure now. So it's no, hang on just a minute. What are you doing here?
Oh, okay.
So this is a good point, because you can just as easily make errors in your test as you can make in your code. And so by having two people look at it, you dramatically reduce how far you'll go before you actually before you discover it. I've seen situations where people have, the test passed and everything. You go look at the test, you're like, that's because the tests either aren't testing anything. It's like you go look at their test and it's saying, assert true, and it just passes it true. It's like, that's not really helping you out very much here. Okay, so we got a failure. I'm looking at the test. The test looks right. I'm breaking the PDD or the TDD pair programming thing by looking at chat stuff as I go. Okay, so we've got this, and okay, so it's not a new character, right? So since it's not a new character, I could do this, right? Here's the stupid simple way to do it. So we'll just go and just do this to see, because we've kind of done that before. When we got to things, we would say, okay, so that passes, and that kind of feels like it fits the pattern that we were doing. But it's also, we've seen an IV before. So what we probably want to do is figure out, how can I get, instead of having this, I want to combine this 10 with this 4. And so one thing I see down here is I've got the string append happening and the recursive call, but I'm not doing that for this up here.
Wait. Are you sure you want, never mind. Are you sure you want to do it for 14?
That's a good point. Yeah, let's comment that out, because what I'm trying to do is get rid of it. If I just add it there, I haven't really accomplished anything, right? So what if I do it for the 10? Does that seem like where we might need it?
That seems more logical.
Okay. Okay, so string append, and I'm going to try to use the same thing we've done down here. And so I'll want to subtract 10 from whatever I give it. I'll convert. Okay. Does that look like that will?
No, you need a greater than or equal to sign.
Okay.
Or else it'll only do that if it's 10.
Okay, so there it passed. Now, in looking at this, I've got something I do for 1, something else I do for 4, something else I do for 5, or same thing again for 5, something else I do for 9. The composite ones we're doing something different for. But is it possible that we can rewrite that in a way that makes it more, like, can we make all these things the same?
You may not have to, but you could.
Well, so, right, we could, but it would also make it more, it would be easier to see what's happening if I'm doing the same thing for each line. So let's try that and see if that works. So if I do this, well, I need to add to it. So then I want to string append that to convert. And this one I want to subtract 9 from it.
So what you're trying to do right now is just make everything uniform?
Right. So I'm trying to come up, can I come up with an algorithm that would work for basically, can I make it to where I've just got all this data that's mapping my Arabic numeral to my Roman numeral, and I do the same thing on everything. If I'm able to do that, then I could maybe eventually even abstract the data out to get down to just what the function itself is. So let's try that. Let's see if that works. And that works. And I'm going to go ahead and do the same thing for all of the, oh, you know what? I didn't change it, did I? Okay, so let's see if that works. Now notice I'm able to run these tests just over and over and over again. It's a very powerful thing to be able to do that. And I make a small change. If something didn't work, or I accidentally select a bunch of stuff and delete it, or I mess something up, I can just, Control Z back, or if I'm checking it into Git. If I'm using Git, probably what I do is every time I make a change in the test pass, I may check that in right at that point, so I can always fail back to the point that it last passed. I'm sure no one here has ever run into the situation where like you make a change and then you try to fix it and you make another change and pretty soon you're so far down a trail but you can't actually fail back, and then it takes you 2 weeks to figure out that you didn't have a comma where you needed it or something like that. That's probably just me, but I've experienced that before. Okay, string append this to, and this was 4, so I'm going to subtract 4 from it. And okay, so those are, let's make sure it runs. Okay, that works here. So those are all working. So let's see, if we're going to add another test, where do we think it will eventually break down?
Okay, you're writing the test now.
Yeah, but I'm going to cheat. I'm going to okay, so these are all working. Another thing, let me just show you something that's kind of interesting with Lisp languages. This REPL over here, I can just call things like that and see what they do. So I'm looking at this, and I think John pointed out what's the next interesting test. I can keep on just walking up. If this was something that was very, very vital to the security of our country, I would probably want to test every single one. But in just looking at this, I can probably start saying, okay, where are the places that it changes? I kind of have an idea of where things will break. So I'm gonna go ahead and jump forward a little bit and say, let me try 19, because that's the type of thing that might be interesting. And in this case, it's going to be IXX, so let's make sure that works. Oh, wait. No, I'm wrong. It actually was right and I was wrong, right? It would be XIX. Okay. Okay, so that worked. Let me jump forward to, let's say, 25. Let's do 24 because that's one that sometimes those are the types of things that I think that will work.
It should run until you introduce a new character.
Okay. So we're pretty sure this is going to, we have reason to suspect this work. And like I said, the amount of tests I will write here probably has to do with how important this thing is. If it's very, very important, it doesn't cost me a lot to write one for every single number we're trying to do. But let's go and jump to 29. So that would be XXIX, right? And that works, right?
Yes.
Okay. So then we're going to go to, oh, actually 39 is what I was thinking I wanted to do. And 39 is going to be XXXIX, right? So that's what we expect to work. So then we'll go to 40, and this is where it gets, where we think we're going to have something not work. What do we decide? Is that what we decided it is?
Extra large. Yeah.
Okay, yeah. So 40, L is 50, so XL is 10 less than 50. So if we do this, now we have a failure. So what do we do next?
Okay, so the simplest thing to do is going to be just write 40 in. Okay. And then we were on a rampage to make it uniform.
Rampage, not a roll. We were on a rampage. Okay, we'll go with that.
So okay, and then run, and it passes. Oh, great. So it should break down here. Let me make sure that 41 still works.
Be XLI, right? For 41?
Maybe.
Yeah, that's right.
Okay.
Okay, that ran.
And I think that should keep on going.
Yeah, so 50 is where we think we'll probably run the next problem, right?
Or would it be 40 or 49?
Okay.
Because I could be wrong on this side. But yes, because you've never.
No. Yeah, you don't take an I away from.
Okay.
You can only take the number that's right below it.
So that would be.
I think it will be XLIX, won't it?
Maybe that seems.
I think that looks right.
Okay, and then 50 will be.
That's when we expect to see a failure, right?
Yes.
Okay, so now we got failure. So in looking at this, probably what we would do at this point is start thinking, okay, does it make sense to go ahead and put everything in here? And it may make perfect sense. And we kind of know where it's every time we introduce a new letter. So we could go through here and add all the Roman numerals for the other letters. And I think, what would we need to add? 100, 500, and 1,000, I think. Usually you think of it going up to 3,999. That would, I think, get us all the way to that if we were to add that. We also might look at this, and some of the things that we've done when we've had more time is go through and start saying, okay, how can I make some type of structure that will represent these things? So we might do something like define, we'll just call it data, and this data will just be a list that maps all these things to each other. So something like
yes, we probably would have to add those.
Yes, good point. We would need to add the ones right before each one. So we might go through and make a list that does something like 50 maps to L. This is kind of how it would look. A hash map would work as well, to where we're just going through and saying all the things that we want to have here. Whoops, that would have to be in like this. And so on and so forth. So we could go through and we could extract the data out of this if we felt it was worth doing. Now, in theory, if we did that, we would then be able to make our convert into a generic algorithm that would work for all types of different numeral systems that kind of look like this. Like, for example, we could potentially switch it out. We could potentially switch it out in order to make it give us images, like images for these letters, and put them together, or something like that if we wanted to. When I've done this in Java, and I've done this on the Lunch and Learn before with this one with Java, there is a hash. It's an ordered hash map that works really well for this, because then you can just use a stream to say get the one that's like just below this but not over it. And you can do most of this in a single line once you've got all the data defined. So that would probably be the approach here of going through this. I'm not going to do this this one right now because one thing I can't. For some of the things we've tried to do this with Racketwid, it ends up expanding to even bigger than what we've got here. So just adding this for the rest of these would probably be sufficient for this. But I'll have to look at the Java record. That's interesting. That's not what I've used for this before. But what do you think? Any questions or thoughts? Is this how you've seen pair programming working before? Is this, or did you experience something that looked a lot different than that? Cool. So John's saying this is how he's seen pair programming work, which is awesome. I've seen lots of people that didn't use it like this, but they usually didn't end up doing it very, very long. Any other thoughts or questions or aggravations? I'm switching. So Rita, you said you saw what very differently, like approaching the problem? Oh, you saw pair programming very differently. Okay. So like the way you've seen people doing it, it didn't look like that, like passing stuff back and forth.
Correct. It didn't look like that. I saw someone telling someone else what to do.
Okay. Yes. Just so one person was driving and someone else was just
Right.
instructing them, so they didn't have to type.
Correct. Correct.
Okay. There are times where if you've got somebody that's learning, it may look a little bit more like that. But if you end up in a situation where the person that knows the most isn't willing to take time at the keyboard, that's usually not a good. It's not really doing pair programming.
I see.
The ideal situation is where you got somebody saying things like, "Hey, you know more about this than I do. Let me drive here and you help direct me because I want to make sure I get this." But then you're still switching off. If you have teams that are doing that, that's usually a healthy sense of how we're working together and collaborating, instead of it just being something of "I'm going to tell you what to do because you're the junior." One kind of red flag with pair programming is when people start being asked to assign their time differently, depending on whether they were the person at the keyboard or the person helping. If they're doing that, then it's because you're thinking more in terms of you got junior and senior person working together, which may or may not be true, but it totally throws off the dynamics of we're working together to discover this as you go, and I'm going to learn from you, and you're going to learn from me. Yes, if the team's already dysfunctional and nobody trusts each other, this would be very hard to implement. When I usually go in with teams that are looking at doing pair programming and things like that, I will usually try to start by driving, even though I'm the person that probably knows the least about what their system's doing, because it's a lot easier to pair with program if they've already seen that I can't type things right and I forget basic syntax and I can't spell when someone's looking over my shoulder. And if you've actually got that experience, then it builds a level of trust to where it's okay for them to sit at the keyboards too. Let's see. Check see. Pair programming 8 hours a day is incredibly draining to sustain for a long time, but adding a third person in mob programming makes the approach much easier to sustain. Yes, and the other thing I'd mention along with that, John, is with a lot of stuff, when you're dealing with cloud things, chances are the information you need to know, having a third person will speed things up more than just than the cost of that person. Just because there's all these intricacies, and if you have 3 people that have done different things, they'll bring a lot more knowledge to it. And a lot of times, particularly when you're dealing with like, okay, we've got this API for the cloud, and I've only used this part, you use this part, and you use this other part. Most of the time, you're just trying to dig through and figure out what the API is for the next step you're trying to take. Cool. Well, that covers what we were wanting to cover today. I will send out a couple links. One, there is a programming course that Benjamin did here recently that's great for learning. It teaches you rackets, but it teaches you the fundamentals of computer science stuff. It's really, really good. I'll send that out because it's worth looking at if you're looking at doing if you're wanting to learn programming or have a kid that wants to learn programming. We'll stick around for a while. If anybody's got any questions, come off mute, and we'd love to hear what you got to say. But thank you so much for coming. It was great to see everybody here today. And like I said, remember 2 weeks, we're going to be talking about test-driven development and ChatGPT. Cool, John, that's interesting. I will check that out. I think I did something kind of similar to that, but using I think it was called a hash tree. Cool. Is there a recording for this session? It will be on the YouTube channel. So if you do a search for, go to YouTube and do a search for Agile LNL, like this. And then go to the live sessions. You'll be under the live sessions. As a matter of fact, it's probably there right now, so you can go find it, or it will be within 30 minutes of when we stop. So check that out. Hey, Troy, good to see you. Thanks for coming. Any other thoughts or questions? Feel free to speak up if you've got any questions about this or anything else. So Dennis, that's a good question. I've seen, and the question is, do pair programmers usually work exclusively that way, or do they switch off? There are sometimes that what you're doing is just typing stuff in. Like you've got a huge spec, a big data definition that you just need to type in, and there's not a lot of value. But that's really a small set of what most programming problems are. So what I've seen teams do is a lot of times you kind of have to enforce pair programming to get people kind of over the hump. Otherwise, they'll take the shortcut of just doing what's comfortable. So I've seen some teams that get together and say, okay, we're going to pair program. No one touches any code unless there's two people looking at it. So you've got to be working with someone else, and they can do it remotely. But you've got to have two people pair programming on it. And then after people get used to working that way, they'll tend to relax it, and the teams kind of get to the point where it's like, hey, I know how to do this. We've done this 10 times. I just need to add another data type for this, or do the same thing we've done in all these different situations. I'm going to not worry about pair. Like for us, it might be, we may say, hey, we've got the format here. Let's just put in the rest of the Roman numerals. And maybe, Benjamin or I could go do that on ourselves while somebody else does something else. Or he's getting ready to leave for lunch or something. And so like, hey, I can knock the rest of this out. We know how to do it. We've got the approach. And so you want to get to the point that you have that flexibility, but it's very, very hard for teams to be able to start without, if they're not familiar with pair programming, it's very difficult for them to reach the right balance unless it's kind of enforced at the beginning of where you're really trying hard to pair program on everything. If a team spends a month pair programming on everything and it's a functional team and they get to where they understand it and they're enjoying it, they'll find the right balance in what they're doing. Mob programming is another great thing that can be very, very valuable. And then you kind of split into pairs and then into individuals. So you got all these different levels depending on what the problem is you're working on. Yes, is there a test for this? I like that. That is a very, very good question to ask. And yes, Astrid, the thing of, say, ensemble or mob programming, where one person might branch off to go do research, or sometimes one person might branch off to go find somebody else in the organization that's done it before and say, I need to go ask them this question. I'm going to go off and do this piece of it, or even just get them and bring them back to the team room so you can ask them questions. So there's lots of rooms for individual stuff still to happen. Okay. Any other questions or thoughts? Well, thank you everybody for coming, and thanks for the great input. And John, I appreciate the code sample there. That was great. I'm gonna look a little bit more at that because that may be another way to. It may work better than what I was using last time I did this with Java. So that's great to see. Yes, especially thanks to Benjamin. So thanks, Benjamin. Okay, well, everybody have a great week. Remember, not next week, but the week after that, we've got the ChatGPT talk, and that's going to be pretty interesting. I'm looking forward to that, and I think that will might be a very interesting thing to invite teammates to if they're interested in any ways that artificial intelligence can be used to improve testing. So thank you, everybody, for coming. We'll see you in 2 weeks, maybe next week if I get an invite put together and out. Have a great day.